Welcome to the Mathematics in my channel. Today we are going to solve another interesting integral questions. So first question, integral from 0 to 1 natural log of x, natural log of 1 minus x dx. And second question, integral from 0 to pi over 2 x times sine of x cosine of x natural log of sine of x times natural log of cosine of x dx. Well, this integral we solved in a previous video. But here in this video, first I am going to evaluate this integral and then try to evaluate this integral and take a relationship between these two integrals. Okay, first we are going to evaluate this integral, and I am going to take this integral is equal to I, and now we can write I is equal to integral from 0 to 1, here natural log of x. Now instead of natural log of 1 minus x, I am going to use a series, so we can write minus infinite sum n is equal 1 to infinity, we know x to the n over n, here dx. Well, now we can switch the integral sign and sigma notation, so here we can write infinite sum n is equal 1 to infinity, here 1 over n is a constant, so we can write outside of the integral sign, here 1 over n and here 0 to 1. Now x to the n times natural log of x, so x to the n times natural log of x dx. Okay, now how to evaluate this integral? Okay, here minus infinite sum n is equal 1 to infinity 1 over n. Now I am going to use a substitution method, integration by parts method. So if we take natural log of x as a first function, so rewrite natural log of x, then d by dx, then integration of x to the n, we know x to the n plus 1 over n plus 1, and here dx, here limit 0 to 1. Okay, then we can write here minus sigma notation 1 to infinity, here 1 over n. Now we know product of these two functions, so natural log of x times x to the n plus 1 over n plus 1, limit from 0 to 1, then minus, and here we know 1 over n plus 1 is a constant, so we can write outside of the integral sign and integral from 0 to 1, here x to the n plus 1. Now derivative of first function, we know 1 over x dx. Well, now we can simplify, here minus n is equal 1 to infinity, here 1 over n, and if we plug in 1, we know natural log of 1 is equal to 0, and if we plug in 0, here 0, so we know this term is equal to 0. And here we know this x, this one get cancelled, and here we have integration of x to the n, we know integral of x to the n plus 1 over n plus 1. If we plug in upper limit and lower limit, we have 1 over n plus 1, here also 1 over n plus 1, so we have minus 1 over n plus 1 square. Okay, now this minus get cancelled, and we can write now this is equal to infinite sum n is equal 1 to infinity, this minus signs get cancelled, and here 1 over n plus 1 square. So we can use partial fraction decomposition, so we can write after the partial fraction decomposition, we can write here 1 over n, then minus 1 over n plus 1, then minus 1 over n plus 1 square. Okay, then I'm going to break this summation into two different summations, so n is equal 1 to infinity 1 over n minus 1 over n plus 1 minus infinite sum n is equal 1 to infinity 1 over n plus 1 square. Well, now I'm going to plug the value, so we can write now I is equal to here if we plug in 1, we know 1 over 1, so 1 minus 1 over 2. Then if we plug in 2, so we can write this is 1 minus 1 over 2 plus 1 over 2 minus 1 over 3 plus 1 over 3, then minus so on. And if we plug in values for here this summation, so we know here 1 over 2 square plus 1 over 3 square plus 1 over 4 square plus so on. Well, now we know this 1/2 get cancelled, 1/3 get cancelled, and other terms also get cancelled according to this pattern. And here we have now 1, here 1 over 2 square, so I am going to add 1 and subtract 1. So if we add 1, we know 1 plus 1, here 2 minus and we should subtract 1, so I am going to write this 1 like 1 over 1 square, because I write this is like 1 over 1 square. I am going to use Riemann zeta function. So here 1 over 4 square plus so on, and now we know this is equal to zeta of 2, and zeta of 2 we know the special value 2 minus 5 square over 6. Okay, this is the answer for first integral. Well, then I'm going to take our second integral, integral from 0 to pi over 2 x sine of x, cosine of x, natural log of sine of x, natural log of cosine of x dx. So I'm going to take this integral is equal to j, and now we know j is equal to 0 to pi over 2. Now I'm going to apply King's property. So we can write now according to King's property, this x should be 5 over 2 minus x, here sine of 5 over 2 minus x, here cosine of 5 over 2 minus x, here natural log of sine of 5 over 2 minus x, natural log of cosine of 5 over 2 minus x. So we can write here first 5 over 2 minus x, then sine of 5 over 2 minus x, we know cosine of x, then sine of x, then natural log of cosine of x, then natural log of sine of x dx. Okay, then we can simplify here. Now we can multiply by pi over 2 and minus x. If we multiply by pi over 2, we can write here pi over 2 integral from 0 to pi over 2. Now cosine of x, sine of x, natural log of cosine of x, natural log of sine of x dx, then minus x times these terms, we know this is equal to this term, so we can write this is equal to minus j, because here also equal to this integral. So here j, here also j, so 2 times j is equal to pi over 2 integral from 0 to pi over 2. Here I'm going to arrange these terms like sine of x, cosine of x, natural log of sine of x, natural log of cosine of x dx. Well, now I'm going to take a substitution. So if we take sine of x is equal to t, sine of x is equal to t, then differentiate, so cosine of x dx is equal to dt, then we can plug in here. So we know here now pi over 2. Now limit integral from 0 to it should be sine of pi over 2 1, so 0 to 1, 0 to 1, and here we know cosine of x is equal to 1 minus here cosine of x dx, we can take dt. Sine of x we can take t. So t, now natural log of sine of x, so natural log of t, and natural log of cosine of x, 1 minus t square, here square root, and cosine of x dx, dt. Okay, then here this square root, we can write log 1 minus t square to the 1/2. So we can write this 1/2, we can write here. So pi over 4 integral from 0 to 1 t times natural log of t times here natural log of 1 minus t square dt. Well, then next step, here we can also take another substitution. So if we take t square is equal to u, then differentiate. So 2 times t dt is equal to du. So we can write now 2 times I is equal to here pi over 4. Now integral from limit also 0 to 1, also 0 to 1, then natural log of t. So we know natural log of t is equal to square root of u, then natural log of 1 minus now t square. So t square we know u, so 1 minus u, then t times dt. T times dt we know du over 2. So du 1 over 2 we can write outside of the integral sign. Okay, then here we know this is 2i. So I is equal to now 5 over here 4 times 2 8, 8 times 2 16, so 5 over 16. And here again we have natural log of square root, so we can write this is natural log of u, and this 1/2, this power we can write in front of the natural log. So here again 1/2 integral from 0 to 1 natural log of u times natural log of 1 minus u du. Well, then here pi over 32, and this integral familiar with us because this is our today video question number 1. This is sorry, here this integral we talk as a j. So here j, here also j, and here also j, and this integral we know I, and we know the value of I 2 minus 5 square over 6. Okay, this is the answer for second integral. If you like this video, please subscribe this channel. Thank you for watching.